This is Mastering Mathematics with your teacher, Karen Weston.
Welcome again to another in the series, Mastering Mathematics. Today, guess what? We should be wrapping up that topic with matrices. Yes, we have been through the whole paradigm of what it is. We have done addition, subtraction, multiplication. We had the adjoint, and we had the inverse, and we had determinant. Today, we are going to show you, do I have to go over the inverse again for you? No, because you're so good in it, right? So today, we are going to show you how we use the adjoint to solve a simultaneous equation. Remember, before we were saying coefficients from the first line is multiplied by coefficient from the second lines. This method now today will teach you how to use matrices to solve a simultaneous equation. Here we are. So again, we would be given the two, because simultaneous means we have two variables and we need the answers at the same time. But the last time we were saying eliminate one. Let us see how it works when we're using matrices. Okay. Now, I don't believe you will be surprised to know that in terms of a matrix, it's going to say, hello, you have to make me look like a matrix. I wear different costumes. So, giving them 8x plus 5y is equal to 4, and 3x plus 4y is equal to 10, says to the matrices, you have to get me in the form of a matrix. How do we do that? The first thing we do is to write a 2 by 2 matrix just using the coefficients of the variable. Watch me and see what I am doing. So the first bracket comes up. It was as if somebody came in and said, I don't know any x's supposed to be in anything, nor y's, so we take them out. Okay, that is what we actually do. So the first matrix then, we would be having just the coefficients, so just these. And we will be forming our first 2 by 2 matrix. So it would be 8, it is 5, it is 3, and it is y. But in terms of mathematics, there is nothing we can throw away. So the x's must figure in what we have done, so too must our y's. So what do we do with them? We give them a house. Yes, we give them a little, you can call it a cell, but they do get a house, so that, and it is a column matrix. The first variable is written first, so that the x will be the first variable, so it is x, and our second variable comes in the second row, the y. So that is the first in terms of saying what we have done. So let's just get that process again. How did we get to this spot? The first thing we have to do is just to get all the numbers, which we're calling our coefficient for our variables in a 2 by 2 matrix. And then we also have to account for the variables, and we make them form a column matrix. And then over here screaming, the constant term says, we are not staying outside, we need to be inside too. So we have to put them in a bracket, and they stay how they are. Okay, so that is the first thing. So we have to get them looking as matrix. So our first thing is to transform the given simultaneous equation into a matrix form. Now, we have to go very slowly because I want you to get this. If we had an equation And so let's just show you. 2x is equal to 10, and we wanted to find x. You would have been saying divide both sides by 2. So we would end up saying x is equal to 10 divided by 2. Okay, so far so good. I want to tell you that in terms of the matrices, they would not be saying divided by 2. They would want to say they want to find the inverse of 2. So they're going to write it as 2 to the negative 1 times 10. All right? Anytime we have an index to a negative number, it is always 1 over. So we're teaching you some side things so that when I get up to the inverse up here, you're going to understand. Let's go again. If we had 2x is equal to 10, if we wanted to find x, it would have been 10 divided by 2. However, we can transform that to write it as 2 to the inverse times 10. And 2 to the negative 1 is the same thing as writing a half multiplied by 10. Why is Miss Weston taking time to say all that? Because it is this principle upon which the inverse is founded in terms of solving the simultaneous equation. You are going to see that our 8, 5, 3, 4, the 2 by 2 matrix would be treated as if it was just a single number. So suppose instead of this, we were just thinking that this was just a 5. All right? If we wanted to find, we would have been divided. The principle operates along the same, that we are going to leave the variables on one side. So it would have been x, y, sorry, the wrong one, because we want to write it in black. So it would have been x, y, staying on this side, is now equal to, and technically it would have been 410 divided, and I'm going to write it and then show you something. It would have been 410, and based on what we have seen here, the 8534 would be acting as the coefficient 2, so it would have been this, and it is divided by the 8, the 5, the 3 with your 4. But in terms of our mathematical procedure, this does not figure as any mathematical form. So what we do, instead of saying divided by 8, 5, 3, 4, we just call it the inverse. So that this part here, what you would have been saying as divided by 8, 5, 3, 4 gets represented as 8, 5, 3, 4, the inverse. Okay? And that is where the inverse of the matrix comes from. We're taking you right back. So let's go again. First step, step 1, transform the matrix, the original simultaneous equation, into a matrix form. How do we do that? We just shake out the coefficients for our variables and we write them to form our 2 by 2 matrix. The variables must be represented, so they form a column matrix. The first variable in the first row, the second variable in the second row. All right? So, and don't forget, it's not going to be x and y all the time. Even if it's s and r, whichever variable comes first is written first, and then the second variable second. Okay? And then we also transform the constant terms into a column matrix. Like everything else, the variables we are after is our x and our y. We have just shown you it operates along the same principle as if you were going to be solving 2x is equal to 10 and our operation that we would do. We have falsified something for you so that you can understand what is being done here. xy then would have been equal to our 410 and it's divided by 8534. But there is no mathematical formation like this, so it is not written like that. It is represented as saying it is the inverse of the matrix. It is also in that form, the inverse is written first. So that from this step up here, having gotten it in the matrix form, we would have been writing xy would have been equal then to the inverse of the 2 by 2 matrix. So it is 8, 5, 3, 4, the inverse, and it is multiplied by 410. Okay, and it is multiplied by 410. We would then have to take an aside and find the inverse of that matrix, 8, 5, 3, 4. So we will now be finding the inverse of the matrix 8, 5, 3, 4. Not so close because it's not 34, it's 3, and it is an 8. All right, the inverse, and it would be equal to, and let's put our little a, our little a, our little b, our little c, and our little d. So if we are using our formula, it's 1 over AD minus BC, and it is times, and it's D, and it's A, it's negative B, negative C. Okay? So then it would be equal to, and it's 1 over, so we're finding the determinant, and it is 8 times 4, A, 8, D, 4, minus B, 5, and it's times C, which is equal to 3. Okay, and then it is D, 4, it's negative 5, it's negative 3, and then it is A, which is equal to 8. All right, so we're working this out, and it's now equal to 1 over, and it is 32 minus 15 times your 4, negative 5, negative 3, 8. And so it is now equal to, and from this we can say, so 5 from 12 will leave us 7, and that's 1. So it's 1 over 17, and it's times 4, negative 5, negative 3, 8. We don't have to go any further with the multiplication. We leave it at that. And then so what we do, the answer that we got for the inverse, is now substituted into our original equation. And so we are going to be writing then that xy is now equal to, the inverse is 1 over 17, and it's times 4, negative 5, negative 3, 8, and it is times 4, 10. Okay, so at this point we will be multiplying the matrix 4, negative 5, negative 3, 8 by our column matrix. Elizabeth, we all right? So we're coming down the road here. Elizabeth is on a timeout this time, so yes, and we're just listening and we're seeing. Okay, I'm now going to take off how I found the inverse. That would have been done, and so we are now proceeding to see how we end up with our final answer. So here we go. So from that, yes, we're still working out, so we're writing back 1 over is still equal to 1 over 17, and we're doing our multiplication, and we know it is row times column. first number by first number would give us 4 times 4, and second number by second number, and it is plus, and negative times a positive, multiplication, negative rules, so it's negative 5 times 10. Okay, first row with first column, that's all we have. Second row now with first column again, it is going to be negative 3 times 4 plus, and it is 8 times 10. Very good. All right, so now we are clarifying. We have inside is equal now to 1 over 17, and 4 fours would give me 16. Positive times a negative would leave you with a negative, and it is 50. Then you have negative 12, and it is plus, and it is 80. Oh, Elizabeth, I need you to help me here again. Why did we leave home our slide rule? Because we have negative 50 plus 16. So again, we're taking the biggest number, which is negative, and 6 from 10 would leave you with a 4. So we're just going to get a 3 here, negative 34. And here is going to be, it's an 8, and it is a 7. Okay? And then, so we're going to have, it's now equal to negative 34. Oh, so messy. So it's negative 34, and it's divided by 17. And because the scalar outside is multiplied by everything inside. And then again, it's now going to be equal to 1 over 17 times 78 will give you 78, and it's over 17. And we can see right away that negative 34 over 17 would end up with our negative 2. And for our second term, 17 into 78 with 4 sevens, okay, 4 sevens are 28, 4 ones are, sorry, 4 eights are 30, 4 sevens are 28, 4 ones are 4, is that right? Here we go again. Let's check back up here and see what I did. 2 from 10 would have given me 8, and 1 from 7. Oh, you see the teacher makes mistake too. Not students alone. You check it again. All right. That is why we say you have to be sensitive about numbers, so you know. Should have been 1 from 7 would have given us a 6 and not a 7. All right, yes, Miss Weston knows her tables, you know, but wrong multiplication too. That is what we call a topographical error. All right, topographical error. And this. So then here we would have been getting 17 into 68, and that would be 4. All right. So what we're doing now is just equating. So we would be coming back and saying our xy would have been equal to negative 2, 4. And in terms of equality, first number with first number, that is where we're going to get x is equal to negative 2 and y is equal to 4. Now we would have been giving you more, but sadly again, our time is up. We're going to wait until we're back from the break to give you some more and to take you step by step through what you are now developing to be a full-time mathematician.
Whenever possible, draw a diagram. Even though you may be able to visualize the situation mentally, a hand-drawn diagram will allow you to label the picture, to add auxiliary lines, and to view the situation from different perspectives. If you know the answer to a question is incorrect and you cannot find the mistake, start over on a clean piece of paper. Oftentimes when you try to correct a problem, you continually overlook the mistake. Starting over on a clean piece of paper will let you focus on the question, not on trying to find the error. Always read math problems completely before beginning any calculations. If you glance too quick at the problem, you may misunderstand what really needs to be done to solve the problem.
Right, that was a mouthful. But as usual, we are working towards an examination question. And I just want to show you now how you would have been using the inverse when you're given this question on the examination. Section 2 is the CXC examination paper. And this came from the January 2012. All right? And look at what it says. The matrix Q is such that Q is equal to 4, 2, 1, 1. Part 1. Find Q to the negative 1. So it says right away, find the inverse. 2 marks tells us that we shouldn't be taking too long on it, okay? So let's go right away. So we have our A, our little b, our C, and our D. And we are ready for them. So the solution. So since Q is equal to 4, 2, 1, 1, then Q inverse would be equal, and we are big because we have prepared and we know. So our A, our little D, AD, which would have been 4 times 1, and it's minus BC, which would be 2 times 1, and it's times the adjoint, interchange 1, 4, negative 2, negative 1. And we're just multiplying out, it's 1 over, and it is 4 minus 2, and it's 1, negative 2, negative 1, 4. And that's just equal to 4 minus 2, so that's just a half, and it's times 1, negative 2, negative 1, 4. Okay? And then we're just multiplying a half times 1 would give you a half. If we have negative 2 and we're taking a half, what are we going to, what's half of 2? Right. So, and it is negative 1. So then a half of 1 is, yes, negative a half. And then a half of 4 is, yes, 2. So don't think about it as any big multiplying out. That's why our fathers who haven't been to no formal school or anything, they can give us these sums and do them quicker and faster than us. Because they're not stopping to say, multiply, multiply. No, they can just say, what's a half of 1? It's a half. What's a half of 2? Right? And it's negative, so it's negative 1. And what's a half of negative 1? Negative a half. And what's a half of 4? 2. Are we there? And that's your answer. 2 marks, okay? So the inverse of that matrix was a half, negative 1, negative a half, 2. Part 2 of the question says, using a matrix method, find the values of x and y in the equation. And this is the equation you're given. It's 4, it's 2, it's 1, it's 1, and then it's times your xy, and it is equal to 8, 3. Notice that these people have done it for you. The simultaneous equation has been transformed in the matrix form. So we know that we are going to be saying since, and so since we're given this equation, then in order to solve it, our xy would now be equal then to 4, 2, 1, 1. The inverse, remember we have been practicing and we went over all that, why it is written in this form, and it is times 8, 3. Notice what you're saying. 4, 2, 1, 1. What did the first part of the question ask for? To find the inverse. So right, so it is xy, and it is equal now to the inverse. It's a half, it's negative 1, it's negative a half, and it's 2, and it is times our 8, 3. So again, we would have been going first number with first numbers is a half times 8, a half times 8, and it is plus negative 1 times 3. Okay, so again it is a negative a half times 8, and it is plus 2 times 3. Now here, what are we getting? So it would now be equal to 4 minus 3, and it is negative 4 plus 6, so that our numbers then are 1 and 2. And so we're coming back to equate xy would be equal to 1, 2, so that for values, x would be equal to 1 and y would be equal to 2. And that is how we are using the matrix method to solve the simultaneous equation. That is the big question. That is on our section 2. Next time, I'm going to ask you to go on the www.cxc.org website. You can get more solution questions there. Get into your textbooks right now. Start practicing. So until next time, when we will be bringing another in the series, Mastering Mathematics, this is Karen Weston and Elizabeth Thompson, who is here as my main supporter, saying goodbye and do enjoy.
Do have a Merry Christmas and a Happy New Year.
Thank you.
Join us next time for another in the series, Mastering Mathematics, a production of the Education Broadcasting Unit in the Ministry of Education and ABS TV.